Welcome to my on-demand session about zero downtime deployments for both Sitecore XM and XP-scaled scenarios. My name is Julius Angwenyi, a current Sitecore MVP with over 6 years experience working with the Sitecore platform. I am a senior Sitecore architect with Avanade. At Avanade, we are Sitecore's first and largest global implementation partner with extensive experience behind us. In fact, we are winners of this year's Sitecore's Global Platinum Partner of the Year Awards. Now let's look at the agenda next. Having a zero downtime deployment is a common pain point facing many of our Sitecore clients today. It means inefficient use of resources to manage deployments, or even potential loss of business during unscheduled downtimes. The good news is this problem can be solved by embracing modern DevOps capabilities. Today, I would like to get you started on this journey. I start by examining into why you find yourself having to resort to Sitecore code or Sitecore content freeze during deployments. I'll then introduce you to the concept of zero downtime deployments as a strategic solution for your Sitecore deployments going forward, hopefully improving your return on investments too. Without further ado, let's jump in. So, why code or content freeze? A code freeze is an adopted milestone from the olden waterfall days. It means no code changes are allowed whilst you are in a release window, primarily to mitigate against introducing new defects or regression issues. A content freeze, on the other hand, means stopping or pausing all your Sitecore content editing activities during a deployment. This is to allow for content-safe deployments with your new Sitecore release. Code or content freeze should be a thing of the past. I'll do a quick whistle-stop tour on some of the pain points facing most clients today, then hopefully share some tips on how to address them. First, a complex Sitecore solution challenge means you have several dependencies to manage, very large code bases to manage, and dealing with multiple languages and frameworks. Another pain point is dealing with complex code match issues, which consumes precious time during your release cycles. Another one being having to manage multiple teams, potentially working in multiple geographies, can be a headache when you're preparing for your releases. Are your deployments not modernized yet? Are you having manual processes, always having to resort to Sitecore content freeze? All right, the good news is, as I mentioned earlier, we have some of the solutions to these challenges. And I start by giving you the first tip here on how to overcome this is to use a robust code branching strategy to help you manage your code base. This is to separate code which has been tested and always ready for deployments from any ongoing work. This will save you time. Another tip to share here is adopting some clean coding principles. Things like solid principles, which your developer should be aware of, or test-driven designs, or even following the Sitecore recommended Helix principles. The point here is you gain more benefits by making your code easier to read, easier to maintain, easier to test. Another tip to share here is embracing microservices architectures. This will actually allow you to decouple your monolith code base, making it easier to manage your dependencies, easier to transition to the cloud, and also some of your delivery teams can be able to work in parallel. Another tip to share here is modernizing your CI/CD processes and taking advantage of automation tooling. A good example to give here is using automated testing can significantly reduce the bugs you have in your Sitecore code base. Also, using containers, for instance, will actually allow you manage dependencies better and also managing the issues to deal with multiple languages or frameworks. One more tip to share here is later on in this presentation, I'm showing you how to resolve the issue of Sitecore content freeze by embracing zero downtime deployments. Let us now refresh ourselves about Sitecore continuous integration and continuous delivery processes. Sitecore is a digital experience platform, or DXP. What we call all-in-one DXP can be hosted in your own cloud or by making use of Sitecore's managed cloud. It's worth mentioning at this stage that the latest direction of travel by Sitecore is towards a composable software as service DXP model. You can read more about this from the Sitecore's website. So for the all-in-one DXP model, the cloud deployments can leverage IaaS, basically VMs, or PaaS, or making use of containers as shown in this infographic. When working outside of containers, you will typically build your Sitecore application and then just push it directly to your IaaS instance or your PaaS instance, let's say running somewhere on the Microsoft Azure cloud. However, when using containers, this process is slightly different. I now run this animation to illustrate how the Sitecore container-based CI/CD flow actually works. So developers make changes to the code base. They then commit the changes into the repo, in this case, stored in GitHub. An Azure DevOps pipeline is monitoring this repository and triggers a new image build each time there's a commit in the repo. These images are built by Azure DevOps, and the new image version is pushed to our container registry. We have other triggers for the base images that we may be using and that have changed. An example is an update to the base Windows image or the Sitecore image can also trigger a new image build to occur. This is where the CI part of the process ends, and we now have our new images built and available for deployments. So a CD element is gonna start and a release element is going to execute to start the deployment process. So the first thing the CD element does is to push the new version of the Kubernetes specs into our AKS cluster, including pinning down the deployments to the unique tags of the new images we have built. AKS will now connect to our container registry instance, pull down the images, and build our new deployments based on them. Of course, a Sitecore deployment isn't complete without a push of the Sitecore content changes. Once the specs have been deployed, the content is then also pushed to the SYM instance and published as usual. Once this has happened, our users can then browse our website and interact with the new containers running in our AKS cluster. Later on, I show how to perform zero downtime deployments with these images now available to us in the AKS cluster. Before we do that, let's also introduce blue-green deployment strategy, plus look at some of the key concepts next. In its purest form, a true blue-green deployment means that we need to have two separate but identical environments. One is live, the blue, and the other one is on standby, the green. This is where the blue-green name comes from. This infographic shows shared resources available to both blue and green environments, such as the databases. This helps actually simplify the architecture for us. We also have a capability of switching or routing our incoming traffic between the blue and the green environments. Moving on, this infographic here shows a fairly high-level CI/CD pipelines for implementing the blue-green deployments. On the top section, it shows The blue environment is currently the production environment, and our end users are accessing this environment. When we have a new version of our Sitecore application, we deploy that to the green environment without affecting our live users, thus achieving zero downtime deployment. Very cool. On the bottom section, it shows our green environment has now become the production environment, and our users are actually accessing this environment. This leaves the blue environment available for us to deploy our next version of our Sitecore application. Blue and the green take turns. The process repeats in each deployment cycle. Later on, I'll be covering how to make use of these blue-green deployments with both the Azure Platform as a Service and Azure Kubernetes Service for the container workloads later in this session. Just to bring to your attention that the blue-green deployments are actually made easier with the cloud. If you haven't adopted the cloud for your Sitecore workloads, then perhaps you need to start thinking about that seriously. Let's look at the Sitecore Platform as a Service, zero downtime deployments next. This is Sitecore Azure Platform as a Service, very simplified architecture. It shows the instance of the Sitecore Content Management, or the CM, running as a web app. The CM is used by your business or your content editors and is usually not accessible to the public. This also points to a master database. The other instance shown here is known as the Sitecore Content Delivery, or the CD, if you like, and is also running as a web app. This is usually the public-facing website accessible to your end users. This points to a web database. For zero downtime deployments, we usually target the CD instance for your end users. However, if you need to, you can also extend this to your CM for your business users as well. The principles remain the same. If we move on to this infographic, where I'm showing a typical Azure PaaS architecture for your Sitecore XP-scaled topology. We have the full XP-scaled topology application roles, as you can see here, which have access to our databases and other services, such as the Azure Key Vault, Redis Cache, Surge, among others. We achieve zero downtime deployments by making use of the blue-green deployment strategy, as we said earlier. This is done by making use of deployment slots. If you're not aware, the standard, premium, or isolated Azure Web App Service plan tiers actually allow you to provision additional deployment slots. In our architecture diagram here, you will notice we do have blue web and the green web databases. This is to enable us to achieve content-safe deployments when we are deploying to our CD instance. This also helps us to mitigate against any content freeze. The rest of our XP-scaled topology resources I shared, as you can see, including the master database. I'm showing also our Azure DevOps organizations here, which typically has access to run our CI/CD pipelines. So what are the steps of achieving this? We'll start by, of course, triggering your release pipeline. The first thing you do is to make a copy of your web database. As we said earlier, this is for allowing content-safe deployments and mitigating against any content freeze. At this stage, both the CM and the blue CD are still pointing to the original web database, and the blue CD is still in production with our live users not affected. Next, we start our deployment of our new Sitecore version to both your CM instance as well as to the green deployment slot. This will now point to the copy of the DB, to the copy of the web DB we made earlier. We then perform our usual deployment, including our content deployment. We do our usual publishing, the building of the Sitecore indexes, and perform any of our tests we want. Remember, all these activities will not affect your Blue CD at this stage, and your live users are not affected because they're still accessing the old version. Next, once we are happy with our green deployment, we can now swap it with our Blue CD. And now the green CD with our new version will become our production instance, and our live users will start accessing it without being interrupted. We have actually achieved zero downtime. Remember, our previous version is still on the Blue CD, which we have swapped out. If you have any issues with the latest version on our green CD, you can always do another swap to roll back. What to mention here that you can manage your CM instance deployment and avoid performing blue-green deployment on the CM instance to reduce the complexity of this process. However, if you really want to make sure your content editors don't have any downtime, you can also do a blue-green on your CM. It's however recommended you manage your Sitecore templates changes such that we make them to be backward compatible between successive releases. This is to reduce the risk of breaking your deployment in the event of rolling back. For example, don't delete your Sitecore fields immediately, mark them as obsolete in your code base, and then you can release them in future releases. You can delete them in the future releases. Now, with the platform as a service out of the way, we now look at Sitecore AKS zero downtime deployments next. Sitecore Container workloads make use of Azure Kubernetes Service, or AKS. I'm assuming you already know what AKS is already. If this is new to you, I highly recommend watching intro videos on Discover Sitecore YouTube channel to get started. This infographic shows us a fairly simplified AKS blue-green strategy, which allows us to achieve zero downtime deployments. How does it work? You need to define a blue deployment for version 1 of your Sitecore application and apply the desired state to your cluster. When version 2 comes along, you also need to define a green deployment, apply it to your cluster, test it, validate it without affecting your version 1 in the blue deployment. Then you gradually start replacing version 1 with version 2 as shown here. Eventually, we all have version 2 now available to our users, and version 1 is no longer being used and can be deleted if no longer required. Moving on, here we have a typical Sitecore AKS architecture for the Sitecore XP-scaled topology. You can see here we have an AKS cluster containing various pods which are running our containers. You can also see the scaled out Sitecore XP application loads running as individual pods within the AKS cluster, which is backed by a Windows node pool. We also have access to the Sitecore databases, as well as other services such as Azure Keyfold, App Insights, our ACR instance, among others. I'm also showing here our Azure DevOps organizations, which of course typically will be running the CUCD pipelines. Similar to what we discussed or we showed earlier in the Azure Platform as a Service architecture, the AKS zero downtime deployments will be making use of the blue-green deployment strategy for both the CD instance or the CM instance, if you like. How do we do that? We don't need to define or we don't need to provision a separate cluster to achieve blue-green deployments. Actually, what we need to do is just define a green deployment within our cluster. So our green deployment plus its corresponding service and labels can be defined alongside the existing Blue deployment. For content-safe deployments, we also need to be pointing to a copy of the web database as we discussed earlier in the platform as a service. Once we have tested and we are happy with our green deployment, we can then switch traffic or routing to point the green deployment. We do this by updating our ingress controller specification and applying that state on our cluster. Now, I'll be running this animation next, and you can see what happens. So you can see here, our end users can access version 2 in our green deployment. Our blue deployment is still on standby in case we need to roll back. However, if we no longer require it, it can also be deleted. Note, as previously discussed in the platform as a service architecture, you can implement blue-green for the SYM if required. So let's summarize the steps we've discussed. First of all, we trigger our release pipeline process. The first thing we do is to make a copy of the WebDB. This is for content-safe deployments. At this point, both the SYM and the blue CD is pointing to the original WebDB, and the blue CD is still in production with our live users accessing it. Then we apply our green deployment desired state onto our cluster. This will create all the green pods with the new version of Docker images and our Sitecore deployment, including content deployment. This will make use of the copy of the WebDB we created earlier. We do our usual publish, repeating of the Sitecore index, and verify the deployment is all right. Then once we are happy with that green deployment, the next thing we do here is to update traffic routing in our ingress controller, and live users can now start accessing our new Sitecore version in the green deployment. In an event of a rollback, again, we just update the ingress controller to redirect the traffic back to the blue deployment. If the blue deployment is no longer required, we can do cleanup to save on resources. You can also make use of Kubernetes update strategies to achieve Sitecore zero downtime deployments with the AKS. For example, you can make use of Kubernetes default rolling updates, also known as ramped deployments, as shown in this infographic. As you can see here, from step 1 through to step 5, the pods are updated in a gradual manner while keeping the old versions online to avoid any downtime. This concludes a look at the Sitecore AKS zero downtime deployments. I hope you found this useful to you. As next steps then, I would highly recommend you explore our Sitecore MVP website as a working example of implementation of a Sitecore AKS deployment. There's a link I've provided here. Please do visit our sitecore.stackexchange.com website if you have any questions, because MVPs and other Sitecore SMEs are answering questions there for you. Also, please join us on our Sitecore chat.slack.com, where we continue the Sitecore conversations as usual. If you have any feedback or you want to reach out directly to myself, please use my contact details I'm sharing here. And finally, let me say thank you for finding time to join me for this on-demand session. Bye for now.